This will be an additional part of review of formulas to help support our work in Chapter 5. So as we look at number 8 here, we're looking for principal of $8,000 is invested in an account paying an annual percentage rate of 5%. Find the amount in the account after 2 years if the account is compounded n times a year. Now, for this, we're going to need to know the compound formula, and I'll write it here for you, and you can write it as well. A equals, that would be the future amount, the principal times, in parentheses, 1, plus R is the rate, N is the number of times it's compounded each year, and then it's raised to the exponent N T, where T is the number of years, and again, N is the number of times it's compounded. So, filling this in, we have 8,000 as our principal, 1, plus our rate is 5% that we convert to a decimal. Our period of compounding in this case, 4 times means quarterly, so 4. And then we need a 4 up there times our number of years, which is after 2 years. So 4 times 2, and I'll just change that to 8 to make it a little easier here. Now, for something like this, you would need to put this in your calculator. And the protocol would be 0.05 divided by 4. Get this, add 1 to it, use a caret, raise it to the 8th power, and then you multiply it by 8,000. So if you have a calculator, you can try this, or later, and I'll pause. And I got $8,835.88. I rounded it off to 89 cents. Now, of this amount, the original amount was 8,000. So the amount of interest, money that you've earned, is $835.89. Now, I'll leave this there. And now we're just going to put a 12 where the n is. And then 2 times 12, this will become 24. So let's figure that out. So again, n is 12 now, and 12 times the 2 years gives me the exponent of 24 here. So I divided 0.05 by 12, added 1, put a caret in, and then to the 24th power, and took that value and multiplied it by 8,000. So as you see here, compounding it more frequently, you get a little bit of difference here. Here it's a 5, here it's a 9. So $4 perhaps difference in interest because you're compounding it more frequently. Okay, let's go on to number 10. Now, going on to number 10 is another typical example you might get where something is in Fahrenheit and they want to convert it to Celsius or vice versa. Now, also what I noticed is that they had the improper numbers here. So this is the formula for converting Fahrenheit, which you would put here, into Celsius. Now, one of the questions we often have when we do things like this is, suppose we wanted to solve for the formula for Fahrenheit. what would that be? So let's solve for the letter F. Well, here to start, we're going to take the reciprocal of this to get rid of the fraction here. So we're going to multiply this as all one term by its reciprocal, 9/5. But if we do this side, then we do this side. So 9/5 C. So we have 9/5 C. And this is all gone now, so I'm just going to erase it. Good technique for getting rid of the fractions. I can get rid of the parentheses now as well. And I want to get this F by itself, so I'm going to transpose that negative 32 to the other side where it becomes a positive 32. And then this is the formula if you have Celsius, how to get Fahrenheit. So we had done something like this, but we want to find out using this formula if it's 53 degrees Fahrenheit, Celsius in Hawaii. What would that be in Celsius? Okay, so we're going to use this formula up here. So 5/9 times, now this is 53 minus 32, that's going to be 21. So when we do the calculation, 5 times 21 is 105, divided by 9 is 11.6, and it repeats. But they want it round to the nearest degree, so again, rounding techniques are important here. So this would be 12 degrees. So 12 degrees Celsius is 53 degrees Fahrenheit. All right, we'll get set up to do the next one. Now, for number 11, here we're saying it's this many miles from Oklahoma City to Memphis, Tennessee. So, find out how long it takes to drive a round trip if the average speed is this. So, first of all, what formula do we use? Well, we're going to use the formula distance equals rate times time. And we're looking for time here. Now, we know the rate is 65. We don't know what t is. That's our time. But remember, distance is round trip. So if this is one way, our total distance, when we multiply this by 2, will be 940 miles. So to find time, then, we're going to divide by our rate, which is 65. And they've asked us to round to the nearest minute. So 940 divided by 65 is 14 hours. And then we get a decimal here of 46.15. Now, that's not 46 minutes. So we're going to have to take that 0.4615 and times it by 60, which is the number of minutes in an hour, because this is a decimal fraction of an hour that we want to convert to minutes. So we take that 0.4615 times 60, and that gives us, when we round off, about 28 minutes here. So 14 hours, 28 minutes. Now, again, you get 14 point this, but that's good for hours. But this decimal fraction is not good for minutes. We have to take that decimal fraction, multiply it by 60, and this much of 60, a little less than half, is 28 minutes when we round off. All right, another type of problem, and we'll just keep moving here, is a package of vinyl floor tiles contain this many square feet. How many packages should you buy in order to cover a rectangular floor that is... Now, for number 12, we're looking at this vinyl floor package of tiles that contain 45 square feet. And we want to know how many packages will we need to cover a floor 120 by 90. So we need to figure out the area of the floor first. So area equals length times width. 120 times 90 is 10,800. But keep in mind now that you're going to cover 45 feet with one package. So how many packages do we need? So we take that number and divide it by 45. And we get 240 packages. Now if this were like 240.3, then you might say, well, I'll round off, I'll only buy 240 packages. But that wouldn't be good because you'd have a little corner without enough tiles. So you'd have to buy 241. Now remember, this one came out even, so that was the exact number. But if it came out with a little fraction, you'd have to get one more package in order to cover that. Okay, let's go on. This coming up on our Hawks software is this one. You pay, let's say, $7 a month for 600 text messages. And then you're going to pay 25 cents for every additional text message. Now your total bill, let's say, was $14. So how many text messages did you send that month? Well, you subtract the 7 from the 14. In fact, let's make this 15 so we don't get our 7s all confused here. Let's say you spent $15. That'll be better. So you're going to subtract 7 from the 15 and get $8. Now, this $8 you have to divide now by 0.25. So let's do that. 8 divided by 0.25 is 20. You sent 20 additional messages that month. That's kind of expensive, but we're just making an example here. So the question is, how many text messages did you send that month? Well, this is the extra you had to pay for, but you also sent 600. So the answer, and where I'm finding on some of the people taking Chapter 5's test, is that they're just saying 20. Well, that's the additional. You have to add the 20 to the 600. So you send 620 messages. Now, if people just figure this out, they're showing the work, I give them partial credit. They just forgot to add the 20 to the original 600 that you paid $7 for. Okay, I wanted to do that one. All right, now for the last one, we have this formula. V equals 4/3 pi r 3. Now we're saying the ball has a radius of 6 inches. And we'll do that here shortly. But suppose we wanted to solve the equation, let's say, in this case, for pi. How would we do that? Well, keeping in mind, to get rid, this is all one term, to get rid of the fraction, you're going to multiply this by 3/4, and this side by 3/4. So you have 3/4 v equals pi r to the third. Now, to solve this, we have to divide out the r to the third, and this would be r to the third. So this one's a little tricky because we have a fraction in the numerator, but theoretically this is the answer. And since this is just an extra one, I'm not going to show you how to do that because that'll just lengthen the tape, but that probably wasn't a good example to work out here. All right, and you could solve for R2 and you'd have to get into cube root, so again, we're not going that far. So let's solve it for what we have here. So volume equals 4/3 times pi, and now your calculator has pi, but usually they want 3.14 for pi. Now your radius, this is critical. Your radius is 6 inches that you're going to raise to the third power. Now you might say I could take that 3 and divide it into the 6 and make that a 2 and get rid of your fractions. Absolutely not. Because the rule order of operations is you do the exponents first. So this is going to be 4/3 times 3.14. Now 6 to the third power is 216. So you see, if you made that a 2 to the third power is only 8. So that wouldn't really match up here. Now let's see, could we take a 3 out of this? And the answer is yes, so we could. I wanted to make it simple, but 3 goes into there once. 3 goes in there 72 times. So now we just have to multiply 4 times what pi is, times 72. 4 times 3.14 times 72. And we get then, the volume is 9,000, or I should say 90,000. No, it's actually I'm reading this wrong here. Okay, 904.32, and they want us to round to the nearest whole number, so we will just drop this, and it's going to be 904. Okay, this was a little shorter than our other one, but still lots of stuff here.